Alright, for this screencast, what we're going to do is answer somebody's question. I think it was Wheat on YouTube. And basically, the idea is I'm going to go ahead and just start a routine. I'm going to call it my rref.m. And the idea is you have a matrix, say 1, 1, 2, 4, and then you have b equals 3, 4. And then you have the system of equations a times x equals b. And then you want to say, okay, well, x equals what? Well, in Matlab, it's really easy. You can do two different ways. You can say, I'm going to just put this over here real quick. I'm going to do a clear, a CLC, a close all. You can do inverse of a times b, and there's your x. You can also augment a and b, and you can make an augmented matrix and just take a and b, put them together, and then do rref of aug.a, and then that'll give you, essentially, aug.a will be the matrix A and the matrix B augmented together, and then rref essentially just does Gaussian elimination on this left matrix, and then the right hand side is 4, -1. This built-in function rref is very, very easy to code, so that's essentially what I'm going to do here. So what we want to do is I'm actually going to leave aug.a in here, and what I want to do is I want to row reduce this matrix, okay? So I'm going to make this a 3 just to show you what happens, and let's see what our new x is. So this is x computed with inverse. And then we're going to do it our own way. So to row reduce this, the first thing we have to do is we have to get a 1 in this section. So I'm going to do this manually, and then I'm going to write a embedded for loop to do this. So what you first want to do is you want to say aug.a. I want to take the entire first row, and I want to set it equal to the entire first row divided by the first element in the augmented matrix A. So that'll be 3. So what you'll see here is that I essentially divided the entire first row by 3. Now the reason why I did that is because then what I want to do is I want to take the first row and subtract it from this second row here. So now I'm going to take the second row, and I want it to be equal to the second row minus the first row times the second element here. So what that means is I'm going to take the entire first row, multiply it by this 2 here, right? 2, 1. That's the second row, first column. And then I'm going to subtract it from the second row and then put that back in the second row. So what's going to happen is I'm going to get a 1 here and then a 0 here. And there we go. There goes my 2 here and 0 here. So now what I want to do is I want to do essentially the exact same thing that I just did here. So this is for the first column. I'm going to do the exact same thing for the second column. So now I'm going to take the entire second row, and I'm going to divide it by aug.a 2, 2. And when I do that, that changes this 3.33 to a 1.0. And then all I need to do is just take the first row and subtract the second row from it, multiplying it by this number here. So what that looks like is I'm going to take the second row, and I'm going to take the first row. I'm going to do the first row minus the second row times that 0.33. And that 0.33 is first row, second column. And there we go. Now I have 1, 0, 0, 1, and if you notice, look here, 0.8, 0.6. So if you go up here, that's exactly what I computed here. Now this only works if I have a 2x2 system. If I add a 3 here, a 1 here, and then I do like 2, 8, 9, and then I put a 5 here, and I run this, this is my x computed up here, this is my augmented matrix, and I sort of get what I wanted. I get a 1, a 0, a 1, and a 0 here, but I don't exactly get the entire thing because I didn't zero out all of this. So what I would have to do is I would have to come in here, copy this. I'd have to do the exact same thing for the third row, take the first row, multiply it by 3, 1, and that will give me zeros in the first column. Then I have to do the exact same thing for the second column. Oop. So then I'm going to take the, this is going to be the third row again. I'm going to take the third row and I'm going to subtract the second row times 3, 2. And there goes a 0 here. But notice that the third column is still all messed up. So basically I have to do the same thing that I was doing before, third column. So in the third column, I'm going to take aug_a of the third row all, and I'm going to divide the entire third row by 3, 3. And there you go. Now I get a 1 here in the bottom. And then I'm going to do the exact same thing to the second row and the third row. So this is very simple, like I was saying. I take aug_a of the first row equals aug_a of the third row, the first row minus aug_a of the third row times, and I have to be very careful here. So I'm going to subtract off the third row, multiplying it by this guy here, which is aug_a 1, 3. And let's see if that worked. And it did. There we go. I got a 0 up here. And then I want to do the second row equals aug_a 2, all minus aug_a 2, all. Sorry, I'm subtracting off the third row times aug_a. And remember, so I want this 1, I want to multiply it by this guy, so that's row 2, 1, 3, sorry. Let's see if that worked. And then now this guy, 0.96, 0.55, and negative 0.152 should be the same as this guy. And it looks like it is. I'm going to go ahead and put I'm going to put this guy down here at the bottom so we can compare. And there we go. They're the same. So again, if I went to a 4x4 matrix, I would have to do this again manually. So that's why I want to use a for loop. So I'm going to pause it real quick. Okay, so we're back. So basically what I want to do is I want to turn this into a nested for loop. So if you notice, this line of code, this line of code, and this line of code look exactly the same. The only difference is that there's a 1, a 2, and then a 3. So that's really, really easy to do. I'm going to say for, and this is row, and this is all columns. So I'm going to say for row equals 1 to 3. And you could even make this more general and say to R, and say R, C equals size of A. You could do that. And then basically what I want to do is I'm going to just say aug_a, and instead of writing a 1, I'm going to do row, all equals aug_a row, all divided by aug_a row, row. And then I'm going to just end it right there, okay? Now, if I run this, I'm going to go ahead and just put a break here, and then I'm going to get rid of the semicolon. Notice that I've got a 1 here. So first, here is my original matrix up here at the top here. Then the first time I went through the loop, row was 1, and I put a 1 here by dividing by 3. Then I went to the second row, and I put a 1 here by dividing by 4, and then I put a 1 here by dividing the entire last row by 9. So I'm almost there. Now what I need to do is I need to do essentially what these lines of code here are doing. So if you notice here, what's happening here is I'm taking the value of this entire row, multiplying it by this number here, and then subtracting it from there. So that's essentially saying for, and I'm actually, what I'm going to do is I'm going to make this just, I'm just going to make this an IDX variable, 1 to C, because they're essentially the same. This needs to be a square matrix. So I'm actually just going to make this variable, I'm going to call it S, S here, and I'm going to do 1 to S, and then 1 to S, and then I'm going to make this IDX, and this IDX, IDX here, IDX, and IDX. And then this is going to be, I'm going to call this JDX, like IDX for index, JDX for IJK, however you want, 1 to S. And so what I need to do is I need to copy this line of code here, but I need to replace it with I and J's DX. So this 2 is actually the J. So every time I see a 2, I need to replace that with JDX. And every time I see a 1, I replace that with IDX. So I see a 2, JDX, and a 1, IDX. Now I need to be careful here. I only do this if IDX is not equal to JDX. And why do I do that? Because this loop is going to start at 1 and then go to S. So it's going to start at the first row and then go to the second and third row. But I don't want it to start at the first row. I want it to skip the first row. But then when I go down to the second column, I want it to do 1, skip 2, and then go to 3. And then when I go to the bottom, I want it to do 1, 2, and then skip 3. So when IDX and JDX are the same, I skip it. So now what we should have is the code should work. And if I grab this X computed here, there we go. I got exactly the result that I was looking for. So I'm going to maximize this, and I'm actually going to go through this in debug mode just to make sure everybody understands. So I put a breakpoint here at line 15. Here's my augmented matrix. Everything's the same. I'm going to step through here. IDX is 1. So what I'm doing is I'm going to take the entire first row and I'm going to divide by FET3. And then that gives me 1 in the 1, 1 slot. Then I'm going to go through here, and now JDX is 1, but remember IDX is 1 now too, so I'm actually going to skip this entire block because IDX is equal to JDX. I come back, and now JDX is 2, so I'm actually going to execute this line of code. So what it's saying is I'm going to take the second row here, the second row, and subtract off the first row, but multiply it by 2, 1, which in this case is the number 2, and that's going to put a 0 in the 2, 1 spot. When I come back, JDX is now 3, and that will zero out the other column. So now I have 1, 0, 0 in the first column. When I come back, let's look at aug-A before I run this code. I've got 0.3, 3.3, and 7.3 in the second column. When I hit next, now I've got a 1 in the 2, 2 block, and then I step through this code 3 times. I skip it when IDX is equal to JDX, and so now I have 0, 1, 0. I come back through here again. Now I've got a 1 in the 3, 1 slot, and then I step through. I get a 0 now in the 1, 3 slot, and then I come back. Now I have a 0 in the 2, 3 slot. I come back. I skip this because IDX is 3 and JDX is 3, so I skip that. The code is over, and I break out. And the end result is 1's along the diagonal, 0's along the off diagonal, and that's Gaussian elimination that will work for almost every matrix. It will not work if 2 reasons. 1, the determinant of A is 0, or 2, so let me say will not work if, and 2 is if row swapping is required. You can add row swapping into your code if you like, but this is essentially naive Gaussian elimination in a nutshell. So I'm going to maximize it just one more time. Hopefully this will help. Zawit, good luck.